find the derivative of that, and then separately find the derivative of this, and then just subtract the two.
Yeah.
Okay. So the derivative of, so what's being applied to W would have to be 2 layers of product rule and then 1 chain rule.
Where's the product rule?
Actually, I guess not. I was thinking like 1/4 log 7, log base 7 would be a product rule. So like you're taking 1/4 of the log. So I guess that could be kind of,
Well, log is a function. What's being plugged into log?
speaking of W, I guess. Yeah.
Yeah, so when you look for product rule, it's a function times a function, which means you need something in terms of W times another thing in terms of W, right?
Got it. Okay. In that case, would we do chain rule here for log and secant?
Yeah, exactly. It's 2 layers, right?
Finding the derivative of secant W and log base 7 of secant W, we do the derivative of the log base 7.
Let's go over to the log derivative rules. So, you know what the derivative of ln x is?
1 over
Something-
x.
It's like, yeah, 1 over x.
Right. Okay. Yeah.
Okay, so then let's think about log, let's say like log base 5 of x. Do you know what that's equal to in terms of ln? So do you remember the change of base rule? Like, for example, usually you use it if your calculator doesn't let you do log base 5. So do you remember what the change of base rule is you'd have to apply?
No, I don't.
So it'd be the ln of the big number over ln of 5. I think we should probably go over where that comes from real quick.
Okay.
Change of base rule for log. Let's say you're trying to find like log base 2 of, I don't know, 70, right? Which means 2 to the what is equal to 70. That's going to be some decimal, but usually it's hard, some calculators don't allow you to change the base of a log. They only give you ln or the standard log base 10. So you can write this in exponential form, right? We're trying to figure out 2 to the what x is equal to 70. Does that make sense?
Yeah, that makes sense.
Yeah, we're trying to solve for x. We can rewrite this as 2 to the x is equal to 70. Trying to figure out the exponent. Then it's usually you take the log base 2, but if you can't do it, then alternatively you can take the ln of both sides. So then you take the ln of 2 to the x, ln of 70, and then now you can use the log rule. Do you know what log rule you can use here?
You can bring down the exponent, right?
Yeah, bring down the x as a coefficient. So then that becomes x ln of 2, right? And then solve for x, which is ln of 70 over ln of 2. And that's what's then these are then equal. Ln of log base, because they're both equal to x, right? Log base 2 of 70 is the same as ln 70 over ln 2. That makes sense?
Got it. Yeah, that does.
Okay, so now let's go back to this problem here. Okay, so let's rewrite. So let's rewrite log base 7 of w. So what can that be rewritten as using the log rule? Let's do x actually, because it's not. Yeah. So what can this be rewritten as using the change of base formula?
Ln of x over ln of 7.
Yeah, ln of the big number over ln of the base, the small number. Okay, and then if we want to take the derivative, we would then take the derivative of both sides, right? Okay, so then what's the derivative of ln x over ln 7?
1 over x over 1 over 7.
Well, what is ln 7? Is it a function?
I guess not. It's just a number.
Yeah, it's just a coefficient, right? And you remember how we deal with coefficients.
Just leave them there. So 1 over x over 7, or over ln 7.
1 over x. Where does the ln 7 go?
I guess in the denominator, wouldn't it? 1 over ln
Yeah.
7 times x.
Right, because it's already in the denominator, so it's a
Yeah.
coefficient, it stays in the denominator. ln 7x. That's how logs work then. Derivative logs work. If you if you deal with a log that has a base other than e, then you have to have this extra coefficient of ln of whatever the base is in the denominator due to the change of base formula.
So I guess we would do 1/4 times 1 over ln 7x times secant of x. So I guess we do w, ln 7w.
Well, what's
Or
being
would you
plugged into the log?
Secant w. So we do ln
Yeah.
7 secant w.
Okay, yeah.
Then multiply it by secant w, or would that just be like that?
What rule are you applying here?
Product rule, or yeah.
Why the product rule?
No, chain rule. Sorry, chain rule.
Okay, chain rule, right? How does chain rule work?
You take the derivative of the outer function, multiply by the inner function, and then take the derivative of the inner function.
Okay, and so then what does this part represent?
The first part, so that would be f prime of g.
Yeah, f prime of g, right? The derivative of the outer function with the inner one plugged in, and then what else do we need?
Multiplied by the derivative of secant w, which is that secant tangent w?
Secant, yeah. So say it again.
Secant tangent. So secant times tangent. Secant of w times tangent of w.
Yeah, secant w tangent w, right? Okay.
Then for the second part, arctangent. So for this, we just take the derivative arctangent of the inner function. So again, we'd have to use chain rule.
Yeah, chain rule, right? Arctangent itself is a function. There's no w that goes with it, right? This is what's plugged in. Okay.
I remember the derivative of arctangent being something. Is it 1 over 1 plus x squared?
Yeah, that's arctangent, right? Yeah, so you're gonna want to memorize that one.
So minus 1/2 1 plus 1 over x squared times 1 plus w over 1 minus w.
How does chain rule work again?
Yeah, I'm just thinking for the first term. So chain rule is f prime g times g prime x. But for the first f prime g, would that be negative 1/2 of 1 over 1 plus x squared times 1 plus w over 1 minus w, and then multiply that by
is that with the g plugged in? Because f prime of g.
So
what's f prime equal to?
1 over 1 plus x squared. Oh, 1 over 1 plus w over 1 minus w squared.
Yeah. G is equal to this. Yeah, f prime of g. Yeah, f prime of g. 1 over 1, yeah, plus this squared. Okay.
And then taking the derivative of 1 plus w over 1 minus w, that's quotient rule. And we would have to, let's see here. The derivative of 1 plus w times 1 minus w minus the derivative of 1 minus w times. So the derivative of 1 plus w, is that just 1?
Yeah.
So 1 times 1 minus w minus negative 1 times 1 plus w.
Okay.
Over 1 minus w squared.
Okay.
We can simplify that to 1 minus W time or minus -1 minus W's
Minus W. Okay, what else?
plus 1 plus W again.
Yeah, plus
I
1
believe,
plus
yeah.
W. Yeah, there's these to cancel out to make a plus.
Mhm.
Okay.
Over 1 minus W squared. The W's cancel out and you're left with 2 in the numerator.
Yeah. Okay.
So then you'd multiply the top. So not top, the 1 over 1 plus 1 plus W minus over 1 minus W squared. You'd multiply that by what we just got, 2 over 1 minus W squared.
Yeah. Okay. Anything else?
I think that's it.
Yeah, that should be it.